appreciate that.
Maybe one professors, if you're 2nd late, you're getting failed.
Do what?
Maybe professor, if you're 1 second late, you failed the semester.
Oh, yeah. Yeah. Sound like a good rule to me. Well, okay. OCO, everybody. I'm tired of saying hello. OCO, right? Are we good on it? Okay. Excellent. Thank you. Radar is our hero in here. So I appreciate her. She's got me fixed up with the doc cam, I think. Okay, so yeah, I'm drawing upon my Cherokee roots. I'm sure you can tell I'm part Cherokee. So instead of hello, today's OCO. Yes, my great-great-grandfather walked to Oklahoma on the Trail of Tears. He was a 9-year-old orphan in 1838, winter of 38, 39. At any rate, enough of that. So, but he would probably, if he could have seen into the future, to known his great-great-grandson is teaching at Rogers State University, even though Will Rogers had not been born yet. So, at any rate, I'm grateful to be here with you today. I love being on this campus. I want to wrap up chapter 5 today and then look a little bit at chapter 6. And then we'll talk, let's see, I guess probably tomorrow my plan is to send something out regarding the upcoming exam and kind of delineate some things you need to focus on there, and we'll talk a little bit more together when we're together next week. So I want to wrap up this chapter 5 on public goods, public choice, and government failure. So we've been talking about public choice theory, and just kind of run through this because I do want to get into chapter 6 today. It's a more important chapter than chapter 5. Yes?
Still not working.
Oh, it's not working. Okay. All right. So it's not working. Okay. All right. Thank you. It's not working. Doc cam's not working. Okay. Well, let's see. I think Dr. J here can improvise. It's a little kludgy of me, but we'll see how this works. I'm going to have to bring my own markers again. Huh. All right, we'll just do a chalk talk, but I don't have chalk. I got a dry erase board, but that's okay. Okay, let's see how to do this. All right, so we've been talking about public choice theory, so kind of want to get through that here a little bit today. Just a few things here. So that's kind of where we are. Public choice, theory. Let me tighten that board. There we go. And let's see if I can get a marker that looks a little better. Okay, can y'all see that okay? Can everybody see it online? Okay, well. All right, so public choice theory, we're talking about failures of the public sector to achieve optimal outcomes for society. So, a source of public sector failure, if you will, kind of market failure, but again, failure of the public sector to achieve the optimal outcome would be public goods and externalities. Okay, so we've talked about that. You need to kind of have an idea of what public goods are. And before that, we talked about externalities. And so somebody tell me what a public good is. What's one thing it's got to satisfy? You remember?
Food.
Do what?
Food.
Food. Well, those are examples of public goods, right? So we could list a lot of things. I mean, food could be a private good or a public good, right? I say it could be provided by the public sector anyway. But there's two characteristics of a public good. Y'all remember what they are? They're non-rivalrous, okay? Remember that? And non-excludable. Non-rivalrous, non-excludable. All right, so by non-rivalrous, I don't know you think if I turn this light off, let's just do a little experiment here, because I don't know. I just wondered if it would be easier to see the board. No? Okay, I'm getting the no signal. Okay, all right. Maybe I got a darker marker up here. I wasn't thinking. I usually have markers in my office, but didn't foresee this today. So non-excludable means that you can't keep somebody else from consuming the good. And non-rivalrous means that your consumption of it doesn't diminish somebody else's consumption. So that's really what a public good is. So a public good can really be provided by the private sector. Okay, I talked about commercial broadcast television last time. So, I mean, commercial broadcast television has these two aspects. Now, of course, we would all identify public TV as being a public good, okay? But private broadcast TV, well, yes, because it's non-rivalrous, all right? So your consumption, if you're at home and it's coming over the airwaves, you turn your TV on to watch a show on commercial broadcast television, that doesn't preclude anyone else from watching the same show. Okay, it's not like everybody else's TV goes a little dim or something like that. And it's also non-excludable. People can consume whatever goes out on the airwaves without paying for it. Okay, so you know you can imagine other goods provided by the public sector, by the private sector that would be let me say that again. Rewind, erase. You can imagine other public goods provided by the private sector. I don't know too much about Elon Musk's Starlink, you know, what all it puts out and so forth, but that's provided by a private entity, and yet it's kind of like broadcast television, right? If you can tune into their signal, and you probably can, and without paying anything, no one's going to know whether or not you're consuming their service or not. So at any rate, so in public choice theory, we talk about the failure of the public sector to provide for optimal outcomes, and that's because of these two things right here. And our hero, Mr. Sam, is here, so maybe he can get us going.
I don't know much.
Is it a little loose thing there? Okay.
Well, I don't know what this shows.
Don't know what it is.
I may not be able to fix it today, but
Okay.
that's very odd.
Yeah, I don't know who, you know, when I watch these programs, I think I'm the only one that uses that document camera, but
Yeah. Looks fine up till.
okay. Oh. Well,
Guess is the board all right for
the board's fine. You bet. You bet. I'll make do. Not a problem.
I'm sure
Thank
we'll
you
have
for
this
trying,
fixed
Sam.
by
Okay.
Tuesday.
All right. Not a problem, Sam. Thank you for trying. You bet. Yeah, we'll just do it the old-fashioned way. I'm an old-fashioned guy anyways. Okay, but I don't like these drawers like that. Okay, so there's examples. You know, the reasons why we with public goods fail to achieve optimal outcome, because you have a problem that's endemic to these two characteristics of public goods, and that is the what problem? Does anyone remember? Is it the Knight Rider problem? The Red Raider problem? It's the free rider problem, right? Okay, we talked about the free rider problem. The free rider problem. You have free riders whenever you have public goods. Public goods are non-excludable. That means you can't keep somebody from consuming the good if they're not paying for it. So, I mean, that's why the private sector will not provide goods that we associate as public goods in the amount we would like as society. The private sector would not devote enough resources to the provision of public goods because of the free rider problem. I think the example I mentioned last time was, I mean, this would be a private solution here is to a public problem, if you will. If the river outside of town had a habit of getting outside of its banks, and everybody in town recognizes that's a problem, and so we said, hey, let's build a dam out there to keep the river back. A private solution would be perhaps, you know, we just we associate voluntarily to go out on Saturday morning because that's when most people are off work, and give up their Saturdays with their shovels to build this earthen dam. Of course, we'd use higher technology today, but just to give an example. The problem, of course, is that that dam would not be built as soon as we would like, would not be built up as high as we would like, and so forth, because of the free rider problem. You'd have a number of folks you might be counting on to show up to volunteer their time, but they're not going to do it. So again, that's a problem with the provision of public goods. Now, a couple other things I want to mention. We also talked last time about the paradox of voting. You have this kind of problem here. I'll just mention this a little bit. Be sure you catch this in the reading. The paradox of voting. Here we go. Generally speaking, if you have 3 options under discussion here, I mean, there's an earthen dam, there's a concrete dam, there's maybe a big ditch we could dig out by the river to divert the water and so forth. Each of those options come with a price tag, okay, and so forth. Well, one thing is for sure is that if you put 2 of those options beside each other on the ballot, and then you take the winner of the first round and run it against the second. Say, for instance, certainly if you had 3 candidates for governor running, or for county commissioner here, and one advocated the earthen dam, the other the concrete dam, and the other the ditch, okay, just kind of a hypothetical example. Then in the Republican primary, say, you may have 2 Republicans. One says, I want an earthen dam. The other says, I want a concrete dam. They run against each other. One wins the primary, primarily on that issue that's at the forefront of everybody's mind. That winner goes on to the general election and faces a Democrat who wants to dig the ditch, all right? So you basically got 3 options, and we tend to order those options, if you will, pairwise. There's lots of other examples, but I'm thinking in terms of the primary and general election system that we have. And so you might have option A, and then you'd have B, and then you'd have C. And I think we could see that you might get a situation where there's no real clear winner independent of how these are presented to the public. For instance, it could be that A beats C, so I'll just say A beats C in the general election, or sorry, in the primary, then A is going to beat C in the general, okay? So this would be in the primary, so I don't need to write this here, I guess, but if A is greater than B, and then A is greater than C, then A is the winner, right? But you could have other situations as well. The thing is, A could beat B, and B could beat C, and C could beat A, and you never know exactly which one of these options is the most popular. This is just one example. A is greater than B, A is greater than C, or we could say A is greater than B, and then, A is less than C. And there's several options here because you have 3 options here, and there's 2 possibilities for each one in an election to be voted up or down. But basically you can have this situation where A is greater than B is greater than C. I'm going to just summarize all these options here in saying you could have A is greater than B is greater than C, but then C might be greater than A because C never did run against A. In other words, we never did put the earthen dam, I'll just write here, earth dam against the ditch. We put the earthen dam against the concrete dam in one election, and then we put the concrete dam against the ditch in the second election. And so, I mean, A beat B, and A might or may not beat C, because in another election, it could be that the earthen dam would lose to the ditch. What I'm trying to say is this is like rock, paper, scissors. So you take 2 of those together, we all know what? rock crushes scissors, scissors cuts paper, but paper covers rock. So we got three options there, and you're just looking at them two at a time in an election. It could be that the outcome could be either A, B, or C. Okay, you might not, at the end of that process in the general election, arrive at the option that's really best for society, or that which is really favored by society. So this is a paradox. Your book talks about this a little bit, a paradox of voting. This is a situation in which society may not really be able to rank its preferences consistently through paired choice voting. So they give another example in your text, and I was going to show you this, but since we're kind of limited in space on the board, you want to be sure and read about the three public goods of national defense, a new road system, and a new weather warning system. Same idea. Okay, so if you take those pairwise, you may get an outcome that's really not in the best interest of society. It's just the way those options were presented to the public. So be sure and read that if you would. Paradox of voting. Also the median voter model. The median voter model, would like for you to look at that just a little bit. Here's these three options again, A, B, and C. What if option A, maybe that's that earthen dam, will cost $300 million, so I'll just say $300. Option B costs $400, and option C costs $800. There's your three options. Now you put a dollar value on these, on the cost, and then you might get some order. There's a, let's see here. Looking here for where that's presented in your text. I guess it's on page 104 of your text. And really, it could be that that the median would be presented in the first election, or not necessarily so, maybe in the general election. But let's just look at it this way. This is the primary election. And so A is against B. So we would put these two together in this population, presented to the population that has three choices. And you can imagine, a third of the population prefers option A, option B, and so forth. Roughly a third. But if these two are presented, only those are the options on the ballot, but we have people in the electorate who are willing also to pay for an $800 million project, then this is not going to be selected in the primary, because 2/3 of the electorate, roughly speaking, are going to favor the $400 option, or $400 million option, over the $300. So if you put these two together in the first election, B will win. Why is that? Again, if you think of the electorate as being roughly in thirds, a third of the people prefer this one, the dam, earthen dam, concrete dam, and so forth, then 2/3 of the people are going to prefer the median or more expensive. Okay, this is the one called the median option. Median means in the middle, right? So 2/3 of the electorate's going to vote for 400 if this one's not on the ballot. Then these two face each other in the general election. Okay, so this one, B, will win the primary. If the primary is just between A and B, B wins the primary, then B against C. Who's going to win this one in the general election? Can you tell? If B runs against C in the general election, again, you got 1/3 kind of in this camp, 1/3 here, 1/3 here. And then 2/3 of the electorate are going to favor the $400 million project or less. So B will beat C in the general election. Okay? B wins in the general. B is the median. I don't think we can see that very well back there. Can y'all see this okay? Median. Hey, looky there. Okay. So the median will win every time. We could select this differently, if you will. We could have in the primary run A against C, taken the winner and run it against B. B will win in the general election. Or we could have run B against C in the primary. B will win the primary. B would run against A in the general election. B will win again. Try those possibilities, okay? What you'll see is that every time, because the median is going to be favored by more than half of the electorate, the median will be selected in the end in the general election every time. So this is called the median voter model. Median voter model. They give you another example in your text. Be sure to read that. So if you got three options and you're going to pairwise vote, doesn't matter in this case how you pair these up, the median, if there's some sort of way to identify which one is in the middle, it could be, you know, by benefit or by cost, that one's going to win every time. Okay, so they give you this theory. It says on page 104 that under majority rule, the median voter will be in the dominant position to determine the outcome of an election. Now, this is why politicians always go to the middle. Now, in the primary, now we know in the United States kind of how our system is currently operating. The more conservative part of the electorate is in which party? Republican or Democrat? I say conservative, social or economic conservatives. It's pretty obvious, isn't it? Republican, I mean it is to me. If you're social conservative or fiscal conservative, you're more likely to be a Republican than a Democrat. So Democrats are kind of in favor of spending a little more money and so forth than Republicans. Okay, so here's the deal though. In the primary elections, generally speaking, the person in the Republican Party who's nearest the median, which is going to be to the right or more conservative, perhaps, of the median for the whole electorate, because the Republican Party is kind of on the right side, on the right wing. So candidates tend to gravitate toward the middle of the Republican base or the Republican Party in a state or what have you. But when that winner emerges in the primary and they have to face the winner of the other party, say the Democratic Party, then those two individuals a lot of times will shift their position a little bit. I get a little cynical about politics a little bit, but they may shift because they want to hug the median of the whole voter population. And for the Republican Party, that would be to the left of the median. The general population would have a median to the left of the median of the Republican Party, but to the right of the median of the Democrat Party. So, you know, I might study that a little bit, this discussion. They give you another example on page 104, the median voter model. But the one that hugs the middle is the one most likely to eventually emerge as the winner in a pairwise voting situation. Okay, so these are two things I'd like for you to go back and look at, spend a little time on: paradox of voting and the median voter model. So today what I'd like to do is go on to chapter 6 a little bit, okay, if we can. So in chapter 6, we're going to look at, just it has a one-word title called elasticity. So we're going to talk about elasticities today. And we will do part of chapter 6 on this coming exam. Okay, and I'll show you as we get a little closer where you want to draw your study up in chapter 6. So today we'll begin our study of elasticity. Now that really good marker I was just using, I hope that's it. Looks like it might be. Okay, so today we'll talk about elasticity. This is chapter 6. Okay, if something's elastic, what do you think of? I mean, if I had a steel bar here and a rubber bar here, okay, I could suspend them from the ceiling, say they're longer than this, and I could hang a weight on each one of these. One of them's going to stretch, the other one may not, or at least much. We all know that rubber is more elastic than steel, right? You ever tried it? I mean, we all know that. So first off, what we see is that elasticity is this concept of how easy it is to change the shape or the size or the quantity of something. Rubber's more elastic than steel because if you apply a weight to each of these, the rubber thing's going to stretch further than the steel bar. Okay? So that's kind of in general what we mean by elasticity. Elasticity really would connote then the ease of which we can change the size of a measurement by applying a force. So if I have, again, a steel bar, maybe just this length, rubber bar this length, I hang a 10 kilogram weight off of each one of these, the steel bar will stretch a little bit, but you're not going to see it. Probably won't be perceptible. But it would if on a microscopic level it'll stretch a little bit. But of course the rubber bar or rod will stretch even further. So we say the rubber is more elastic than the steel bar. So we would have a way of quantifying this elasticity, this response of a quantity in some dimension to an applied force. We could talk about the percent change in its length divided by the weight that's applied. Okay? And for the rubber rod, that would be even greater than it would be for the steel rod. Okay? We do the same thing in economics. We have a way of measuring a response. The response. So this could be quantity demanded or supplied. We'll get to both of these. Due to an applied force. Hope that made sense, a little thought experiment that we just did. The applied force, though, would be a change in price. Okay? So when I say an applied force, this would be a change in price. Now, I'm not trying to make this difficult or anything, but I'm trying for us to use a little logic here, if you will, in seeing what this concept of elasticity is in economics, how it parallels the way we would use it in other classes. So if you look in fact, I actually taught college physics years ago, okay? And these are kind of things we'd measure in the lab. I mean, believe it or not, I did. So, I mean, I've been all over the place. So you could imagine doing an experiment like this and taking a ratio of the response to the applied force, and you'd get some sort of measure of elasticity. Same thing here. So in other words, if you change the price of a good, we could do the following. I'll just call this E for elasticity. We could look at the percent change in the quantity demanded. See, I'm using a little shorthand there, but what this is the Greek letter delta for difference. Percent difference in the quantity demanded divided by the percent change in the price of a particular good. So this would measure the response, that's on the numerator, due to an applied force, which is in the denominator. Because when you change the price of any good, markers, change the price, you're going to change the quantity demanded. There'll be a percent change in the quantity demanded by the market that'll result anytime the price of gasoline goes up or goes down, say. Okay? So your book defines this as the price elasticity of demand. Usually we put a subscript on this. This is on page 126 of your book. So we'll just say E sub D is the percent change in the quantity demanded. We'll get to quantity supplied in a little bit, divided by the percent change in the price. This is called the price elasticity of demand. And I wanted to write this out because we'll be looking at other elasticities in a minute, and I want to make sure you get the word order right. Okay, there's a little, we have to be a little precise here in using some of these terms like elasticity. So I hear people say, oh, that good's more elastic than this one over here. Well, it's a sloppy way of talking in economics because there are several elasticities. This is just one. So to make sure you're clear about what kind of elasticity you're talking about, you have to kind of pay attention to this word order. There's a word here, price, and there's a word here, demand. I could substitute something else here and something else here. Like I said just a moment ago, we'll be talking about measuring the response of a good that's supplied to a change in the price. So there's something called price elasticity of supply as well as price elasticity of demand. Okay? And as you might imagine here, this would be a percent change in quantity supplied, say of wheat in the market or gasoline or whatever it is, divided by a percent change in the price of gasoline or wheat or whatever that particular good is. So the word order is important. First off, you think of this as being like the cause. And this is the result. It's a change in the price causes a change in quantity demanded. So we talk about price elasticity of demand. We could look at income elasticity of demand. Oh, okay. So nothing happened to the price of gasoline, but everyone in a region experienced an increase in their income. Well, they're going to purchase more gasoline, right, or demand more gasoline. So we'll have these things like income elasticity of demand, price elasticity of supply, even an income elasticity of supply. That's kind of rare. But then we'll talk about the prices of goods outside of this particular market. For instance, there are substitutes for gasoline. Okay, you don't have to buy gasoline to get back and forth to work. There's the price of bus tickets, or there's price of electricity, or other things that you might use, energy you might use to get back and forth to work. So you have complements and you have substitutes. In that case, you'd have a substitute for gasoline. So we'll talk about something called the cross price elasticity of demand, where you're looking at this other good that could either be a substitute for gasoline. Again, bus tickets, price of bus tickets goes up. That's called the cross price. How would that affect the demand for gasoline? So if the price of bus tickets goes up 10%, the quantity demanded of gasoline is probably going to go up too, because people who commute back and forth to work have to choose between those two goods. So if the bus tickets have gone up, they want to buy more gasoline. Okay, so what we're doing here is we're putting some structure on something you already kind of have an intuitive feel for. You already know that, yeah, if the price of bus tickets goes up, we're going to want to purchase less gasoline. Okay, you already know that. We have a way now of quantifying that response. Or again, when we're talking about a particular good and how it responds, its quantity demanded in the market responds to a change in its price, we have this thing right here. Okay, and this is where we're going to start. Okay, so, and I don't have use of the document camera. Well, okay, let's see. So I was going to put some of this stuff up here. So y'all bear with me here. Okay, so this is called the price elasticity coefficient, percent change in the quantity demanded of a product, we'll say product X, divided by the price of X. All right, now, so for instance, just e.g., the price, and I like to use gasoline a lot, but there's lots of other things we could use. We could use lumber and we could use home prices and so forth, but just the price of gasoline increases 10%, just kind of like overnight. Price of gasoline increases 10%, and that could result in a lot of things. That could result in a percent decrease in the quantity demanded of gasoline by 5%. Now, one thing you know for sure is that because of the law of demand, if one of these variables goes up, if P goes up, quantity demanded has to go in the other direction. It's got to go down, right? We know that ceteris paribus. We've talked about that. As long as nothing else is changing, those two variables move in opposite directions. So, price of gasoline increases, then the quantity demanded would have to decrease. But we can measure then how elastic, what we say price elastic. There'll be income elasticity later, as I said, and so forth. But when we're looking at the demand side of the market, we can look at price elasticity by taking the ratio of these two values right here. Okay, so E sub D is what? Well, there's a decrease of 5%. So this would be a minus 5% over an increase of 10%. So you see I got a fraction there, right? So this is a negative 1/2 or negative 0.50. Negative 0.50. Now, because we know that the law of demand will always constrain these two variables to move in opposite directions. Quantity demanded always moves oppositely of the price movement, that this thing here would always be a negative. The numerator and denominator will always differ in sign. One will be negative, the other will be positive. The fraction itself would then have to be a negative value. So here's what we do in economics, at least for this elasticity, not for all elasticities, but for this one, we just take the negative off, okay? Strike that. You always know it's negative, okay? So when we talk about, say, gasoline here, we know it has a price elasticity of demand of 0.5. Now, so what's that's suggesting here is that percent change in the price, like I'm hanging a big weight, I guess you'd say, on this little bar here, a great big heavy weight is not really changing the length of this thing by very much. So this is like a steel bar maybe. Okay, put a big weight on it, you're going to stretch it a little bit, but not that much. Because this thing here, this fraction here is less than 100%. Okay? It's less than 1.0. Now, we have a line of demarcation, if you will, where we generally or broadly classify all goods in their price elasticity of demand by whether this value here is greater than 1 or less than 1. So we're saying that you have a small response to the quantity demanded relative to the applied change in price. Does that make sense? Okay. Now, of course, we'd have a different E sub D if we had different values in here. I guess maybe I got green. Let's try this just a little bit. What if the price of gasoline increases by 4%? And the price of gasoline increasing by 4%. Let me just doctor this up even more. I don't want to make it confusing, but let's say it decreases. Okay? So the price of gasoline decreases by 4%. That would have to be an increase in the quantity demanded of gasoline, right? They move in opposite directions. So that would cause an increase in the quantity demanded of gasoline by 12%. Okay? So in green, let me write it this way. Okay? The percent change in the price of gasoline is a negative 4%. This will cause a percent change in the quantity demanded of 12%. Of course, these always have to be opposite in sign. So what's E sub D, class? What do you think? Well, it's this number divided by this number. 12% divided by 4% is 12% divided by negative 4% is a negative 3, right? So we take the negative off and we'd say that this good has a price elasticity of demand of 3.0. So you see what I'm doing here? Yes. Yeah, Chris, you got it? Okay. Yeah, all right, great. So again, here we see a good whose quantity demanded is very responsive to an applied force. So this is like the rubber rod, right? A rubber band or something. You hang a weight on and go, whoa, like this. Okay, so it's much more responsive. This particular good down here we call a price inelastic good, okay? Because its quantity demanded doesn't change much in the face of a change in price. This one's said to be price elastic. So let me summarize it this way. How do the categories work? Let's see where I can write. Let me write down here. If E sub D is greater than 1.0, like this one up here, that's greater than 1.0, we're talking about a price elastic good. If E sub D is less than 1.0, it's inelastic. Price inelastic. I'm going to write the word price up here because we'll talk later about income elasticities and so forth. And then if E sub D is equal to 1, we say it's unit elastic. Unit elastic. Okay? So generally speaking, kind of within a fairly broad range of prices, goods can be categorized in certainly this or this category. There's a few, not very many, that just happen to have a price elasticity of 1.0. That's kind of like hitting that spot on the wall with a dart. Pretty hard to do, but it happens from time to time. Most goods are either price elastic or price inelastic within broad ranges, okay, of prices. All right, so we'll be talking about those different kinds of goods in a minute, okay. Some goods, I'll just throw one out here. Insulin, you're diabetic, price of insulin goes up. Guess what? You're not going to buy less insulin, not much less. You might try to scrimp a little bit. So the quantity demanded of insulin is very price inelastic. It doesn't change very much at all in the face of a change in price. Other goods, we'll talk about here in a minute, luxury goods. My wife and I are planning a cruise. You know, finally found a cruise with the prices down here and so forth. That's kind of a luxury thing. So if the price of those cruises, those cruise tickets went up 10%, we'd probably say, no, we don't need that. See how you respond differently to a change in the price of a luxury item compared to a change in the price of a necessity. Okay, so gasoline, by the way, is kind of a necessity for the most part for the economy as a whole. So it tends to be a price inelastic good. However, over time, if there's been an increase in the price of gasoline, if you give people enough time, they'll find some way to get back and forth to work without buying gasoline. It's kind of hard to do in the short run, but in the long run, it's a little easier to do. That suggests then that the price elasticity of demand for a good like gasoline can vary, can change, given the length of time you allow for people or consider people to find substitutes for the good and so forth. So we're going to come back to that. We're going to look at what determines the price elasticity of demand. What factors will determine what E sub D is for any particular good. Now, I gave you these percent changes here for these two goods. In general, you're not given that, okay? In general, you may look at the demand schedule for a good and you have to calculate these percent changes. Okay, so let's look at how that would work. First off, your book says this, and this is worth remembering. This will kind of reduce some of the work for us. This percent change in the quantity demanded of the good. Okay, let me just put this in the box. There we go. I'll not erase that. But can be calculated this way. This is the difference in two prices, P2 minus, quantities. This is Q2 minus Q1 over the average of these two. Now your book writes Q1 plus Q2 over 2. When you average two numbers, you add them up, divide by 2. But I'm just going to write it this way because it's easier to look at. Average of Q. And then down here, this would be P2 minus P1 over the average value of P. If you do this calculation here, when the prices are given and the quantity is given on the demand schedule instead of the percent changes, you can equivalently find the price elasticity of demand. Okay, so to give you an example here, I was just going to throw this up here, but let's look at an example. Well, do it this way. I'll use this here. There's a picture in your book. Oh. Okay, so they give you a demand schedule in your text that looks like the following. It says that at a high price, no one wants to buy. These are tickets for a concert, I guess. So I'm going to write this demand schedule. If the price of tickets is $9, well, no one would want to buy. So let's just start with $8. $8, and we're going to lower the price of these tickets incrementally. Okay? This is tickets to a concert. So we do our market survey and so forth. We know at a price of $8, there'll be some tickets demanded. There'll be 1,000 tickets. So I'm going to do this in thousands. 1,000 tickets demanded. Okay? So if the price goes down, would there be more or fewer tickets demanded? Going to be more, right? Because these move in opposite directions. So we're just going to look at 2, 3, 4, 5, 6, 7, and 8,000 tickets. Okay? So these kind of could have used different numbers. It doesn't really matter. But I'm going to plot this in a demand curve. So remember, price is on the vertical axis, quantity demanded or supplied would be on the horizontal axis. So at a price of $8, so 9 is like here. So let's see if I can put 8, 4, 6, 2, 7. How about that? Okay, and I'll do the same thing here. Okay, so this is 1, 2, 3, 4, 5, 6, 7, 8 thousands. I haven't done this sort of thing in years because I used to teach math. So anyway, you can slap one of these coordinate systems up here. But you see when P is 8, quantity demanded is 1. So the ordered pair would be sitting right about here, right? So I could kind of do this little thing here. This would be, again, for this point right here, price is 8, quantity demanded is 1. I'm going to write 1,000 here and $8. And I wrote that first because that's on the x-axis, but it's your dependent variable. So you just got to be clear about that. But it's the 0.81 really, essentially. Okay, so at any rate, I could plot all these others, like this one here. Okay, so when the price is 7, quantity demanded is 2,000. So you see how you pick up this point and so forth. So I'm going to see if I can do this. You get a linear demand curve, kind of like this, and it looks like this. Okay? It goes to that point right there. So what we could do is we could calculate for this good here, tickets to the concert, we could find the price elasticity of demand by using this formula. And what you'll see, it depends on where you are on this curve right here. So let's find E sub D. So you say find the price elasticity of demand for this good here. This is tickets to a concert. Tickets to a concert. Well, this question here by itself is a little incomplete because we're going to see, if we do a couple of these, we're going to see the price elasticity of demand for this good depends on the price of this good initially. In other words, is this a good that's priced way up here at a high price, or is it down here? The price elasticity of demand for this good is going to vary along this demand curve. So, in fact, what we're going to see is if I take the midpoint, see if I go halfway up here, that'd actually be 4.5. Sorry. Which would be here, because it actually goes up here to 9. So somewhere here is the midpoint. That point right there, we're going to see in a minute the price elasticity of demand is 1.0. We'll see that in a minute. I had some graphics I'm just going to plop up here for you to see it a little easier. But what we see is that the good will be elastic up here at a high price, price elastic, and it'll be price inelastic down here. We're going to see that in just a minute. Okay? And the reason is, just kind of using your common sense for a moment, at this high price up here, the good is kind of viewed as a luxury. Okay? And so the quantity demanded is very responsive to a change in price. Down here, it's not considered to be a luxury as much. Okay? And we're going to look more at, again, those things that impinge on the value of E sub D. But say table salt is not a luxury. You got to have it, right? It's a small part of your budget. So things that are a small part of your budget, you don't really think about whether you have to have it or not. If the price doubles overnight, you're apt to go ahead and buy it in the same quantity. Okay, so it's inelastic. Things are inelastic at cheap prices, typically speaking, and they're more elastic up here. So we're gonna prove that out here in a minute. In fact, we're gonna find the price elasticity of demand between these 2 points right here. Okay, so what we're gonna say is we're going to lower the price, or the price will decrease from $8 to $7. In this range right here, there is an E sub D, a price elasticity of demand, that we will calculate by using this formula here. This would be P1 and this is P2. The initial price is 8, the second price is 7. Correspondingly, if you lower the price from 8 to 7, then the quantity demanded will increase from what? From 1 to 2,000 tickets. Okay? So from 1 to 2, and I'll put the decimal in here, 1,000 tickets. Does that make sense? In other words, I'm moving from this point A to this point B. And between those 2 points, I can apply this formula here to find this particular good, tickets to a concert, its price elasticity of demand. Okay? Because this is P1, this is P2, this is Q1, and this is Q2. Let me just go ahead and put the decimal in here. 1,000 to 2,000 units or tickets will be demanded when the price falls from $8 to $7. So this would be a reasonable question for you, for an exam or what have you. What's the price elasticity of demand in this region? Okay, what's the price elasticity of demand in that region? Well, we're not going to use this formula here. We're going to use this one here. E sub D is the second quantity minus the first quantity. So that's 2.0 minus 1.0, 1,000, over the average. And what's the average of 1 and 2? Add them up, okay, 1.5, right? 1.50. So I'm going to take that fraction, if you will, and I'm going to divide by this fraction. The second price is 7.0, and the first price is 8.0. And I want to divide that by the average of 7 and 8, which is 7.5, right? So they call that a complex fraction, okay? But at any rate, I want to take 1 over 1.5, that's the numerator, 1 over 1.50, and I want to divide that by a negative 1 over 7.5. And I really don't need the negative number. I can strike that off anytime I want, because that's the convention in economics for price elasticities, not for your other elasticities, but it's always going to be negative, so we just take that off. And so you got a fraction divided by a fraction. If you think back to school a little bit, how do you solve or simplify a complex fraction? Is you invert the denominator and multiply. I still remember my So I'm a 7th grade teacher, something like this. Invert the denominator and multiply. So this is 1 over 1.50 times 7.50 over 1. So just take 7.5 and divide by 1.5. Make sense? 7.5 divided by 1.5. So if you got a handy dandy calculator, just reach, and 7.5 divided by 1.5 is 5.0. 5.0. This is the price elasticity in this region right here. Here, E sub D is equal to 5. That is to say, a small change in the price is going to affect a big change in the quantity demanded. That ought to make sense if you think about it, because this is an expensive good up here. So you tweak the price a little bit, and that's going to have a big effect on the quantity demanded. In fact, how big of an effect? We tweaked the price a little bit from 8 to 7, so you shave 1/8 of the price off, and you doubled the quantity demanded. So this good is very price elastic in this region. Okay? Does that make sense? Now, we could do the same thing down here. Actually, there's these 2 points. Because I'm doing this without using my ruler, let me just tell you that the point 3, 6 and 2, 7. So this is 3, 6. What do you know? I hit right on it. And 2, 7. Here's points C and D. This is A and B. This is C and D. We're below the midpoint now. Remember, that's the midpoint. I went halfway up and halfway over. The price elasticity of demand is 1 right there. It's greater than 1 up here, like it's 5 and so forth. Down here, say in this region right here, we can calculate the price elasticity of demand. We'll see it's less than 1. Okay? So let's just do that. Okay? So, same sort of thing here. E sub D in this region here, E sub D, using our formula, it's Q2 minus Q1. So it's the second quantity minus the first quantity. That's 7,000 tickets, or 7.0, minus 6.0 divided by the average, 6.5. Okay? That's the numerator. Denominator is what? Well, now you're looking on the price axis. So this is P2 is 2 minus 3 over 2.5. 2 minus 3 over 2.5. Okay? Does that make sense? So this is 1 over 6.5 divided by negative 1 over 2.5. So take the negative off and you get 2.50 over 6.5. You see that? Invert the denominator and multiply. So let me go down here. Am I still on camera? Okay. So E sub D is what? Invert the denominator and multiply. So the 2.5 will be on top. The 6.5 will be on the bottom. All right, so take 2.5 and divide by 6.5. Well, for sure you're going to get something less than 1, right? So 2.5 divided by 6.5 is 0.38462, about 0.385. 0.385. 0.385. So this number is less than 1, which says below the midpoint on this curve, we're in the price inelastic region. Okay? So the good is price inelastic at a low price. It's price elastic at what would be considered to be a high price. Now we say high price for what? You need more information than to say, if I said $8 is a high price, you'd say, well, for what? Okay, right? For what? And there's lots of things. I mean, $8 is a big price to pay for a gallon of gasoline. But it's not for a new home or an acre of land, right? So, and it could be a cheap price for gasoline if you're making bazillions of dollars every year. So not only, does the price of gasoline kind of affect its price elasticity, but also your income. There's lots of things that could affect, and we call these the determinants of price elasticity of demand. And we'll be looking at these in turn. But again, the point here we're trying to make, first off, is this is a response over an applied force. This is the way you can calculate it. Between a segment of the demand curve between two nearby points. There's other ways of calculating this, but I'll tell you that because we want this calculation to be independent of whether prices go up or down, then we divide by the midpoint of these two, or the average of those two. So for instance, if you go from $8 to $10, what's the percent increase in price from 8 to 10? Okay, it's 25%, right? That's a quarter, man, that's 25. But if you go from 10 and you fall to 8, the decrease is 20%. Okay? So that's why we divide by the midpoint. We don't like to have to think about, is the price going up or down? If you're going from 8 to 10, that's a lot bigger percent change in price than it is from 10 to 8. So let's just divide by the midpoint. And so they call this, if you want to get technical about it, they call this the arc elasticity, price elasticity of demand, because we're calculating this thing over an arc or over a segment. There's something called the point elasticity and so forth, which is pretty close to the same thing. All right, so if you got an idea here of what price elasticity of demand is and how you calculate it, that for me is the most important thing that you get down coming up to exam 1. Okay, there's a lot about elasticity that we'll be using in this class. And so I feel kind of comfortable about requiring this of you on the first exam. Okay, so I will be, like tonight, putting some problems up for you where you'll have a demand curve or a demand schedule given, and I'll ask you to compute the price elasticity of demand over a small region. And then tell me, is the good in that region elastic or is it inelastic? One thing you want to just hang on to now, it'll make things simpler for you as we go on. Again, for a linear demand curve. There's other demand curves, but we start with this. It's the simplest case. For a linear demand curve in the upper region, that is above the midpoint, it's a price elastic good. In the lower region, it's a price inelastic good. It's a unit-free measure, okay? Because really you're talking about the percent change. You see, this is measured in thousands of tickets, and this is in thousands of tickets. So thousands of tickets cancel out here in the numerator, and you just get a percent change. So it's a percent change divided by another percent change down here, and those percents cancel. So it's just a number. You may look at this number here, 1.0 or 5.0, and you notice I didn't say dollars per gallon or anything like that. The price elasticity is just a number. That is, it has no dimensions. It's comparing one thing to another, and we already kind of know what it is we're comparing. So it has, it's a dimensionless quantity. We eliminate the minus sign again on this one, but not in general for other elasticities. Okay, we'll look at here in a minute. Now there are some special cases. You need to think about this as well. I talked about insulin a while ago. Insulin is about as close to, of any good that I can think of, to being what's called perfectly inelastic. So you can have perfectly inelastic goods and perfectly elastic goods. Okay? Let's think about that just a second. Any questions on this before I? Okay, so let's look at perfect elasticity. Okay. A perfectly inelastic demand will correspond to a vertical demand curve. P and Q, and here's a demand curve. This is demand curve, market demand curve. What this suggests is regardless of what we do to the price, you could double the price the quantity demanded is going to be the same. The quantity demanded is inflexible, completely so, with respect to any change in the price. Perfect inelasticity. Perfectly inelastic goods will have a vertical demand curve. Okay? The quantity demanded, Q, quantity demanded here, Q, is not going to change. So if one of your variables doesn't change, you're either going to have a horizontal or vertical line. In this case, a vertical line, because this variable, the Q variable, is not changing. Now, I mentioned gasoline a while ago. If suddenly the price of gasoline doubled overnight, it would be a very price inelastic good, because it could be, this is a limiting situation. I mean, this approximates what's going on, but a very steep line. If the price of gasoline doubles overnight from P1 to P2, so that's approximately twice this, then there'll be a few people phone in and say, I can't come to work today, but not that many. And so Q1 would just be slightly bigger than Q2. Okay? So this is nearly perfectly inelastic. And again, gasoline's a good example for me to cite here. There's some others, but the thing is, our behavior is this way. If you just woke up in the morning and heard there's war going on in the Middle East and all the gasoline suppliers are alarmed and they're already doubling the price, you're still going to go out, okay, I've got to get to work today. Okay, you're still going to buy gasoline. Maybe your behavior's not going to change much for the first few days. Over time, however, it could be that the demand for gasoline kind of looks like this, that curve gets a little more horizontal. And now, say a month later, this might be the demand for gasoline, the market demand. What are we suggesting here is that gasoline has become more price elastic. It may become nearly price elastic. That is to say here that at some point a change in price will cause a big change in the quantity demanded. That makes sense? And so, I mean, the limiting case is this, okay? There are some goods, for all practical purposes, the market demand curve is a horizontal line. This is not quite horizontal. It's close to it. But when your demand curve is horizontal, that is what's called a perfectly elastic. Perfectly elastic demand. Okay? Perfectly elastic. I mean, I could have put a little slant to this and it would have really driven this home, but the increase from P1 to P2 is microscopic. A little microscopic percent change in the price really changes the quantity demanded by a lot. So that would be a perfectly elastic. Now your book talks about what kind of goods belong here and here and here and here. Kind of think about 4 categories, if you will. Okay? I talked about insulin here just a moment ago. Perfectly inelastic. An example would be insulin. Why? Because that's a necessity. Okay? All right, thank you. Table salt's another one, would be close. And you say, table salt, what? Well, the thing is, table salt, we all buy it. But if the price of table salt were to double overnight, boom, boom, is that going to affect the amount of table salt you buy? No. Why? For a different reason this time. Okay, for a different reason than for insulin. Why for table salt, do you think? Price of table salt doubles, Morton table salt doubles. One of those little thing goes from $2 to $4. Why are you still going to buy table salt at the same amount? What do you think? I mean, I would, wouldn't you? And why? What do you think? Because table salt is a small fraction of your total expenditures over the course of a year. So something that is a small, okay, so if you start thinking about things, necessities like insulin, small fraction of your budget, or expenditure, small fraction of your expenditure. Those are the two biggest things that would cause a very small price elasticity of demand. There's some other things, but primarily those are the two. Now, a luxury versus a necessity. A luxury is going to put you down here, or something that's a big fraction of your annual expenditure is going to put you down here too. Okay, because we kind of look at necessities and luxuries not in isolation, but we kind of compare them with their prices. So, I mean, these cruise tickets that my wife and I are buying when at Christmas we're going to go on a cruise, that's kind of a luxury, but you know, we're not thinking about it that much because, you know, they're kind of cheap right now. We're kind of down here, the demand curve for those kind of down in this region right here. It's kind of like, well, if I heard that, you know, the price between now and the time we actually order them goes up 10%, that's not going to affect us too much perhaps if they're already cheap to start with, okay? So how do you judge whether something's cheap or not? Well, one thing you ask yourself, is this something I got to have? Right? Something you got to have. If I got to take a cruise to get down to Mexico to get some treatment that I can't get in the United States or I'm going to die, then $2,000 a ticket's cheap, right? But if we're just going to go down there to go lay out on the beach, $2,000 a ticket's a lot of money, you see? So these things are related to each other. Whether a good is a necessity or not, and the price of that good to start with, they're kind of related to each other. So at any rate, your book talks about these extreme cases, perfect elasticity and inelasticity, and then they look at the determinants of price elasticity of demand. And so that I think it's kind of late in the chapter, okay? But kind of an overview there is kind of what I'm talking about. So I'm having a thumb through this because I was not going to. Okay, let me go to this then. Okay, so your book kind of late in chapter 6 will talk about determinants of price elasticity of demand. What determines this? Ultimately, it's like, what determines where you are on the demand curve? All right, so one is, as I'm talking about here, is substitutability and portion of your income. So we're kind of done with this, so we just got a couple minutes left. And so let's do this. This is called determinants of E sub D. All right? Now, use your common sense here. Use your reasoning, okay? Thank you. Substitutability is one. Substitutability. Are there any substitutes? Okay, the more substitutes there are, the more elastic. Let's think about that. More substitutes, then the higher E sub D, more price elastic. So if there's lots of substitutes, if there's other things we can do, my wife and I can do over Christmas break than take a cruise and still have a good time. If there's other things we can do, that's a price elastic good. We say, that's not something we have to do. But again, there's no substitute to cruise tickets. If I have to buy a cruise ticket to get down to Mexico to get some life-saving treatment I can't get in the United States. So that substitutes. Okay, there in that case, E sub D would be low. Okay, so we're just about out of time. She's signaling me here. Number 2, let me just say proportion of your income. I mentioned this with a table salt. Something that's a high proportion of your income, high proportion would be a higher E sub D, and so forth. So read about determinants of price elasticity of demand, if you will. Those are two. The time to substitute. Remember my example of gasoline. Time is another one. How long do you have to make a substitution? The more time you have to make a substitution, the higher the E sub D will be. Okay. All right. Is it a luxury or a necessity? Basically, that's the last one we can.